Hi everyone. In this video we will talk about heating curve. We will be talking about common examples that you have learned over the time starting elementary school. So right now we're going to assume that you have a beaker sitting on the hot plate since we cannot use Bunsen burners anymore. So we're going to talk about hot plate. So it is a hot plate, and in this beaker you have some ice cubes. So here is the ice, and there is a thermometer in the beaker. Okay, so when you start heating this ice, of course, common sense that it is going to melt because ice is taking the heat. So if I plot the graph, here is the ice and you're heating it. So temperature is going on y-axis, okay, and energy is on your x-axis. So we know that temperature is directly related to kinetic energy. If we increase the temperature, kinetic energy increases, means particles are moving faster. Anyway, right now the hot plate is on, the ice is being heated. So as the ice is gaining the heat, you see the temperature is increasing, and a point comes where ice starts melting. So here is the melting point for the ice. Okay, it is 0 degrees Celsius. It is supposed to melt at 0 because it is, I assume it is ice, which is water. So 0 degrees Celsius. So you are heating the ice and a point came where it started melting, and as you see on the graph, the temperature doesn't change again, although you're continuously heating it. So it is sitting on the hot plate, it is being heated, but the temperature is not rising anymore. It will stay constant at 0 degrees Celsius until all of the ice has been melted. So the heat that is going in is being used to overcome intermolecular forces. Okay, we have to remember these terms. To overcome intermolecular forces means it is the particles are holding each other very tightly. So it is breaking those forces so that it can separate them, it can melt them. So the process is known as what? What is going on right now? The process is known as melting. Okay, it is converting the solid into liquid. So this is the melting. So as long as that melting is happening, the temperature will not change because all of the heat is being used to overcome intermolecular forces. Right, we call it IMF. This question is going to be on your test. So make sure you understand the word intermolecular forces. Okay, so once all of the liquid has been converted into, all of the ice has been converted into liquid, temperature starts rising again. And a point comes where it starts melting, boiling. So this is the boiling point. Okay, this is the boiling point. And for water, what is the boiling point? 100 degrees Celsius. So, and the temperature again doesn't change until the all of the liquid has been evaporated. It is converted into gas, and then temperature starts rising again. So the temperature did not change here when it was going through a phase change. So here is a phase change, and what is that phase change? Melting. And then temperature did not change again, it stayed same until it was going through another phase change. And what is this phase change? It is vaporization. So vaporization means you're converting a liquid into gas, and this is all gas now, so the temperature starts rising again. So it's very hot steam. So this is called the heating curve, where you have solid here and then solid turns into liquid. So we have two phases, solid and liquid together here. Then this is all liquid, okay, and there are two phases, liquid and gas, and this is all gas. So going back to this heating curve, okay, as I said, this is solid and then 0 degrees Celsius. So I believe this is this heating curve is for water, and then solid is turning into liquid, that is called melting, and this is phase change. Temperature does not change during phase change because it is overcoming intermolecular forces. And then this is all liquid. Liquid goes into gas, and what is this called? Vaporization. Another phase change, and this is all gas. Okay, Now this is a heating curve, and going backward will be the cooling curve. That if I take this gas and I cool it down, and this is the point it will start condensing, so gas converts into liquid, that is called condensation. Okay, once it's all liquid, it's cooled down, okay, and it starts freezing. So this is a freezing point, just like this was the melting point. Okay, this is the freezing point. So freezing point and melting point is the same thing. The boiling point, okay, or the condensation point is the same. So this is all liquid cools down until it starts freezing point, and then freezing means liquid turns into solid. This is freezing. Okay, and this is all solid. So it's like you put the ice into the freezer. So there are different phases. You have melting, vaporization, condensation going backward, and freezing going backward. Now, which of these are endothermic, which of these are exothermic? Common sense tells you that you were heating here, okay? So melting only happens when it absorbs the heat. So as I showed you on the picture, that it is absorbing heat to melt. Okay, the heat is going in. So all of these phases that were absorbing the heat are are, are going on heating curve. So this is endothermic, and this is also endothermic. But going backward is exothermic. We take the energy out, and that is exothermic. So temperature, as you increase the temperature, kinetic energy increases. So where on the graph the kinetic energy is increasing? Because kinetic energy is directly related to temperature. So I see temperature is increasing here, I see temperature is increasing here, and I see temperature is increasing here. So these are the only stages where the kinetic energy is increasing. Okay, kinetic energy does not change during phase change. So here kinetic energy does not change because there is no temperature change. So what is changing when kinetic energy doesn't change? It is a potential energy that is changing. So potential energy changes during the phase change, and the kinetic energy changes during the temperature change. So we have to talk about solid, liquid, and gas, temperature changes, and kinetic energy changes. So we have a heating curve here. Okay, we have phase changes. Okay, vaporization, backward, and we have kinetic energy that changes here whenever there is a temperature change, and potential energy changes here. Okay, these are endothermic going up, and it's exothermic coming down. So we have to memorize, not understand it basically. If you understand it, there is nothing to memorize. So we need to complete this heating curve, and again, this is a picture of the cooling curve. You have the gas, you lower the energy, the gas turns into liquid, this liquid, and then you turn this into solid, and this is solid. So this is called cooling curve. So kinetic energy is decreasing. Okay, kinetic energy is decreasing during the cooling curve, and kinetic energy was increasing during the heating curve. So go ahead, take all these notes, and the rest we will discuss in class. Thank you.